So thank you, dear participants, for joining today's session. It is 13th day, training day regarding our online training on SPSS. It is 26 March 2024. We are basically covering the online training on SPSS 27. The time is 9 p.m. to 9:40 p.m. Myself, Zahid Bashir, I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab, Lahore. So, what we have covered till date, we have covered a lot of topic, and we were considering the mean comparison based on single group mean. Yesterday, we have concluded some part of single group mean comparison, and we will cover two group mean comparison, more than two group mean comparison the upcoming days. Correlation regression, regression assumptions and diagnostic regression cases, exploratory factor analysis, discriminant analysis, cluster analysis, process by Hayes, and power analysis, which is basically the sample size estimation. So today we will cover the remaining part of single group mean comparison based on myriad at once. So these are the topics that we would cover today. Yesterday, we have covered the first example of single group mean comparison using normal data. Uh, Yesterday, we have covered the first example of single group mean comparison using normal data. Today, we will cover the second example of the single group mean comparison as well as the single group mean comparison in case of not normal data, for example, 3 and 4. So these are the two main subtopics for today's discussion for single group mean comparison measured at once. So this was the example that for which I have provided a data for your consideration. Let me explain this for your consideration. Imagine we have collected a random sample of 31 energy bars from a number of different stores to represent the population of energy bar available to general consumer. The label on the bars claims that each bar contains 20 grams of protein. So there are some energy bars like energy drinks we normally take. So these are 31 in number, and each bar basically the company claim that each bar must contain 20 grams of protein. So that is a standard weightage of each bar. This is the basically standard weightage which they claim, which the company claim that each bar must contain 20 grams of protein. So we have taken 31 energy bar as a random sample. So what is the requirement? We need to test whether the energy bars have protein different from 20 grams. So in order to test this variable, we need to set the hypothesis first. There is no significant difference between the average grams of the sample energy bars and average grams of standard energy bars. So standard energy bars means the bars which contains 20 grams of protein, while the sample energy bars may contain either the similar weightage or maybe different weightage, maybe higher or lower weightage. So our null hypothesis is there is no significant difference between average grams of the sample energy bars and average grams of standard energy bars, and our alternative hypothesis is there is a significant difference between the average grams of the sampled energy bars and average grams of the standard energy bars. That is basically the requirement of this particular example. So this is how you construct the null hypothesis and alternative hypothesis. The null hypothesis indicates that there is no difference between standard energy bars. This is basically the weightage of standard energy bars and this is basically the sample energy bars. So in null hypothesis, we assume that both are same. The sample energy bars, the weightage contained in sample energy bars is same as standard energy bars. If you see the wording of null hypothesis, it says there is no significant difference. It means they are equal actually. While in case of alternative hypothesis, we assume that uh, sample energy bars are not equal to standard energy bars. They may not be same. They may be different from each other. That is why not equal sign is placed here. So you can create your hypothesis either in the normative way by writing the sentence case, or you may establish your hypothesis just like this in the symbolic way of creating the symbols like this. So both are giving the same sense or same conditions, that the null hypothesis indicates that the sample data and the standard data is equal, while alternative hypothesis indicates that sample data and standard data is not equal. So what we need to do before considering the example 3, let us check the data for this particular example I have shared with you in yesterday. It was not normal data, and in this data I have shared data is normal. And here is example 2 data set. You need to extract this into your folder, like we are discussing this one, SPSS and Day-13. All right. What we need to do, we need to check our data set that contains in SPS 27 Day-13. Now this is the example 2 data set. If we need to check this data set so that we can verify the number of observation here. So you can see the data contains the grams of approximately 31. Basically these are 31 because they start from the second row. So these are 31 in numbers. So what we need to do, we need to open our SPSS 27, and in the same way that we have used yesterday, we need to open this data. We need to import this data because this might be in CSV format. So we need to open this data in that format. We need to import this data in our SPSS software. So we may run the analysis in the same way that we have conducted yesterday. So what we need to do, we need to finalize how this uh, hypothesis is either accepted or rejected. So the SPSS 27 is open. Now you need to go to the file. You need to go import, and you need to click on CSV data, because this data is basically the CSV data. So we need to go Day-13. It is not CSV. We need to change the format. Yes, this is XLX data. Basically, you can change the file type. If it is not showing with CSV, you can change the file type. Either it is CSV or it is XLS data. So this format of data is XLS. So you need to double click on it, and it will automatically load or import the data in the format. You need to click, you need to follow the step-by-step procedure that they have provided. So you can see here the data is imported here for 31 observation, and you can verify that it should be measured using scale. So what we need to do, if you remember, we have 2 steps as a part of our procedure. We have 2 steps. The first steps contains uh, in order to check the normality of the data, we need to go to analyze, we go to non-parametric test, go to legacy dialog box and go to one sample KS. Click on it and you need to put your variable into the test variable list and you click on OK. And it will give you one sample KS test. You need to see the asymptotic sig value. If this value is less than 5%, it means your data is not normal. But if this value is greater than 5%, it means your data is normal. So if you see this value is greater than 0.05, it is approximately 20%. If we multiply with 100, it becomes 20%. So we can say that our data is normal. So once it is proved that the data is normal, you need to go to analyze, go to compare means, and you can choose one sample t-test because it is used for one sample when the data is normal, because normality indicates that our data is normal because this value is greater than 5% or 0.05. Therefore, we need to use one sample t-test as a method of comparing our mean or testing the hypothesis. So click on it and you will find your variable. You need to put this variable into test variable. Now you need a test value, which is basically the standard value given in your data. So what is the claim of the company? The company claims that each bar must contain at least 20 grams protein. So this is the standard value. That is basically their claim. So we need to put this standard value, which is 20 grams. So we need to put it here as a test value 20. We need to put here 20 as a test value and click on OK. And you will find one sample t-test here. Now you need to see the t value and sig value. The t value, if it is greater than 1.96, it means there is a significance difference, and the p value is also less than 0.05. So these two value indicates that your null hypothesis is rejected. So what was your null hypothesis? If you remember, the null hypothesis was there was no significance difference between average gram of sample energy bars and average gram of standard energy bars. So if your t value is greater than 1.96 or p value is less than 5%, your null hypothesis is rejected. So what we are going to accept, we are going to accept our alternative hypothesis, which means there is a significance difference between average gram of sample energy bars and average gram of standard energy bar. So that is the conclusion of this second example. So this is how you can conclude. You can conclude in the same way that we have discussed yesterday, but for your reference or for your analysis procedure, I can include here uh, the interpretation. For example, first of all, I need to put here the position for normality. Here you need to put the decision regarding your normality first, so that you can decide which basically option you are going to use for checking the mean comparison. For example, first of all, I need to put here the decision for normality as the asymptotic sig value of, if we see here, this was the asymptotic sig value to tail is 0.200. So as the asymptotic sig value, uh, sig value of one sample KS test is greater than 0.05, which is equal to 0.200, which is greater than 0.05. Therefore, therefore, uh, the data is normal. As the data is normal, we need to compare the mean using one sample t-test. Now, this is how you would interpret your normality first. So, in order to confirm the normality of your data, you need to use the one sample KS test. And then, in order to verify your sample estimations, you need to write here the mean comparison interpretation here. For example, as the t-value of one sample t test is what is the t-value? If you see here, the t-value of one sample t-test is 3.067. 3.067, and sig value is what is the sig value? If you would see here, the sig value, that is 0.005. 0.005. So you need to put here in the bracket. It is greater than 1.96, and it is less than 0.05. Therefore, the null hypothesis is rejected. As the null hypothesis is rejected, therefore, we conclude that there is a significant difference between average gram of sample batch and average grams of standard batch. So this is how you can conclude. You need to write here conclusion about hypothesis. So this is how you can conclude. If you see, the null hypothesis was stating there was no significant difference because the p-value was greater than 1.96. So this null hypothesis was rejected. And we need to accept this hypothesis, which states that there is a significant difference. It means this one was rejected and this one was accepted here. So what is the next thing that we need to consider here? Next is the third example that we are going to use here. This example is basically relevant to sign test. But first you need to open the relevant data. I have already shared both data files with you. If you remember, data is not normal. This file I have already shared yesterday with you. So you need to open this file, and here you will find two data set, example 3 and example 4. You need to extract both data set, right click on it and control E, and you need to specify where you want to locate these data. For example, I would like to locate these data into my today's training. So I would click OK, and it will go directly to my today's training data. So here is example 3 data set and example 4 data set. So I am referring to example 3. Now, you need to understand example number 3, that how it is different from the previous examples. So first, let us read this example in order to have some clarity. What does it mean and how it is related? So a company claims that it pays a median monthly salary of rupees 50,000. The first thing that you notice here is that the company is paying the median monthly salary, not mean monthly salary. Median is also a central tendency. So whenever you have some median data, it is the first indication that the data would not be the normal data. It is the first indication. So a company claims that it pays a median monthly salary of rupees 50,000 to its employees. So this is their claim. They says that they pays 50,000 to their each employee. So the company provides a detailed list of monthly salary of its 1,207 employees. So can we conclude that there is a difference in median monthly salary of 1,207 employees? So this is the median monthly salary, and we have some data of around 1,207 employees relevant to their monthly salary. So we need to check the example number 3. Let me show you the data relevant to example number 3. Now, this is the data, example number 3. If you would open this data set in order to see, there are two types of data. The one contains the rounded figure and the one contains the complete figure. Basically, this salary is in US dollar. So in order to have some clarity, I have converted it back into the full figure. It means a person is receiving 9,466 rupees. Another person is receiving this. Another person is receiving this. So we are basically concentrating on this data. So we need to open this file. We need to import this file actually. Go to import, go to Excel, go to example P. It is not showing in XLS. Check for CSV. Yes, in CSV it is showing. So you need to click on OK and open and just wait for the further steps for its process. Click on next, click next, click next, click next until the process is complete and click finish. And you will find two types of data. One is in digits form and one is in complete form. So you need to consider this data because it includes the full format of data while it contains the decimal points data, which we can use for decimal points. So what we need to do next, uh, in order to have some initial process, we need to create the hypothesis as a first step. So we claim that there is no significant difference between the median monthly salary of sampled employees and standard median monthly salary of rupees 50,000. And our alternative hypothesis would be there is a significant difference between median monthly salary and standard median monthly salary of rupees 50,000. You can state your hypothesis in this way. Your standard median monthly salary might be equal to the sampled monthly salary in case of null hypothesis, while your standard monthly salary may not be equal to your sampled monthly salary in case of alternative hypothesis. So what is the next step? Steps are, first you need to check the normality in the same way that we have used. The second is the decision about the appropriate test. The third is the mean comparison based on appropriate test. If you remember, I have elaborated this procedure. You need to go for checking the normality to analyze non-parametric test, legacy dialogues, one sample KS. You need to put your variable into test variable list and press OK. If asymptotic sig value is greater than 0.05, its mean data is normal. In that case, you are going to use the one sample t-test. But if your asymptotic sig value is less than 0.05, it means your data is not normal and you are going to use the Wilcoxon signed test, which is non-parametric procedure. So first of all, we need to check the normality of our data using. All right. There was a interruption in my internet connection. Now the connection is restored. So I am going to share the screen again. So I was telling that I am going to use the process again for testing the normality. So you need to open your data set first, and then you need to go to analyze, go to non-parametric test, one sample KS like this. You need to put your cell variable in the test variable list. You need to click on OK, and you will find a result like this. Now, if you see the asymptotic sig value, it is less than 5%. So when this value is less than 5%, it means your data is not normal. If you remember here, I have told here that in case if your data is not normal, your sig value would be less than 0.05. So in this case, we are going to use the non-parametric procedure for mean comparison, which is Wilcoxon sign test, because our sig value is less than 5%. If you can verify this value from here, the asymptotic sig value, it is less than 5%. 0.05. It is less than 0.05. So what we need to go, what we need to do, we need to use the non-parametric procedure. So how can we choose the non-parametric procedure when our data is proved to be not normal? So this is the usual procedure of testing the normality that I have used here, as our asymptotic sig value is less than 0.05. So what we conclude here, uh, since the level of significance asymptotic sig value is equal to 0.001, which is less than 0.05, therefore the normality assumption is not fulfilled. What is our decision? As the data is not normal, therefore one sample sign test will be used for testing the hypothesis. Here we cannot use the one sample t-test because the data is not normal. Always remember that whenever your data is normal, you are going to use one sample t-test for comparing the mean for one sample. But if your data is not normal, then you are going to use the one sample sign test for comparing the mean or comparing the median. So what we need to do, uh, uh, first of all, you need to understand what is one sample sign test. The one sample sign test is a non-parametric procedure or non-parametric statistical test used to determine whether the median of a single sample data differs significantly from a specified value or standard value. It is a non-parametric alternative to one sample t-test when the assumption of normality is violated and when dealing with the normal or not normally distributed data. It determines whether a statistical significance difference exists between the median of a non-normally distributed continuous data set and a standard. This test basically concerns the median of a continuous population. So one sample t-test is a non-parametric version of one sample t-test. uh, this is the one sample sign test. So one sample sign test is a non-parametric version of one sample t-test. Similar to one sample t-test, the sign test for a population median can be one tail right or left, or two tails. So you can use it. So what are the assumptions? The assumption includes that the data must be continuous, like in our case, the salary. The data is not normally distributed. We have used one sample KS test for verifying this assumption. A random sample of independent measurement for a population with unknown median. The distribution of such data is non-symmetric because normality assumption is not fulfilled. So, what is the SPSS procedure for sign testing? We need to go to analyze, we need to select non-parametric, we go to legacy dialog box, and then we select the binomial. This is the path of applying the one sample signed test for one sample testing in case of not normal data. So here we need to put our variable into test variable list, and you need to put 50% in the cut point box and press OK. You can put 50%, or you can also put 50,000 salary if it is not mentioned there. The amount you can put 50%. So binomial test requires, because median basically assumes the middle of the data. So we normally assumes 50% as a median value, as a standard value. So if the binomial test indicates a sig value less than 5%, it means your null hypothesis would be rejected, and there is a significant difference between sample average value and standard average value. But if your binomial test value is greater than 5%, you are going to conclude that there is a significant difference. There is no significant difference between these ones. So this is the path of testing the procedure. You go to analyze, you go to non-parametric test, legacy dialog box, and then you need to choose the binomial. And then from that, you need to put your test variable here, and you need to put the proportion. The cut value is 50,000, which was indicated in your example. But as we are considering the median of the data, and median means the central value, which is the 50%, so you need to put it here. So after doing this, you will find a value of sig value, which is less than 5%. So you need to conclude that your null hypothesis is not accepted here. So what we need to do here, we need to apply the procedure here. We go to the analyze button, because we have concluded that our data is not normal. So we go to analyze, we go to non-parametric, legacy dialog box, and then we need to choose binomial. This is the option which is required for one sample sign test. You need to put your variable in the test variable. Test proportion is already 0.50, while in the cut point value, you need to put your standard value, which is provided in your example. So what was the standard value? Your standard value is 50,000. This is your standard value or median value. So you need to put this value here. Yes, in the cut point, 50,000. You need to click OK, and you will find binomial test results like this. If you see the sig value, it is less than 0.05. So I have indicated if the sig value is less than 0.05, it means your null hypothesis is rejected, and you are going to conclude there is a significance difference between both. So what we have concluded that there is a significant difference between the median salary and the sample salary. So this is the conclusion. As the sig value is less than 0.05, therefore H naught is rejected. We conclude that there is a significant difference in the median salary of 1,207 employees as compared to 50,000 standard monthly salary. So this is how you can conclude this question. This next question is for drill. A company claims that a new training program result in median increase in job satisfaction. The manager of the company collected job satisfaction increase data from the employees of the company. You need you have the following requirement. You have some data. Uh, I will let you know the median value for this. So you need to consider the data, for example, number 4 for your analysis, like this data. So it is the end of today's session. Do you have any question you can ask Ms. Hina and Ms. Rabia? Do you have any question, both of you?
No, sir.
All right, Ms. Hina.
No, sir. No, sir.
All right. So stay blessed. Let's meet tomorrow for another part. Thank you very much for joining. Stay blessed.